this little chart here, I talk in terms more in layman's terms than he does because I'm not that as technical as he is. I talk in terms of firmness and forgiveness, okay? And the solid tapes that he talked about, the vinyl tapes, are all firm. It's like having a rubber stamp. You just, basically print the line work. And again, 3M has many densities of foams, and they go from low density to high density. Especially on the hard vinyl tapes, even though some work is that fine line work that has a copyright, like a TM or a C on it, and that would logically make you think that you want to use a vinyl tape for it. That's not necessarily true because it's a pretty difficult label to do. Sometimes you need a little more forgiveness, if you will, and so you move on to the foam tapes. Does everybody have all these tapes in a press room? They don't, okay? And I'll talk a little bit more about that in a minute, but all the award-winning, when people enter into contests for labels like a TLMI or FTA, a lot of these guys do have all these tapes, and they fine-tune the printing, okay? They basically figure out which tape is perfect for all those little labels that they're doing. But in general, they'll land right here dead in the middle, and he told you about that before, this 1000 series or 1015, in our little world is 15 mil tapes. But right in the center is where they'll land, and that's called a combination tape. It's a standard combination tape, although the ones that are a little more firm or a little softer on both sides of it are also combination tapes. But pretty soon you'll figure out what tape works best for you. Is there a big difference in the brand of tape? Some people ask me that, whose brand is best? Well, there's differences in brands of tape, and all the manufacturers we represent, we're distributors, and when you're a distributor, you're locked into the quality of the product that you're distributing. So we're real careful and not to distribute tapes that are marginal. So again, we're 3M distributors, Harley, Tessa, and we've got a couple others that we're involved with, but they all make foam tapes and hard tapes. 3M makes a bigger product line, a lot more different densities of foam. So that's why we brought this literature to show you that. This is a classroom setting. Let's see. Any questions for me, guys? You guys have anything? I know you're pretty new to the industry. It has to be industry related, by the way. No? Well, I just wanted to add on to what Jeff had talked about. He's going to give a talk in a few minutes about plate mounters and all that. But again, just in general, you're going from a vinyl tape, and that's for the line work, solid reverses and all that. And then you step into the world of foams, and you go from these are high density foams all the way over to the extreme of a low density foam. And you don't have to have all these tapes in your press room. Pretty soon you'll figure out many converters have a hard vinyl tape and a foam tape. Some will only use a combination tape and try to get away with that. But the other thing I want to say is that some people use a real soft tape and try to do all this work in their shop. They run into a wall eventually. You can't do that and really have the best of both worlds. But again, most people will land right in the middle with a combination tape.
What kind of tape would you recommend for printing a screen and a solid on the same plate?
If it were me, I'd aim right again at this medium density foam in the middle, and 3M has one. Tessa has a medium density foam, and I would work from there. Generally speaking, you can get away with that. Any other questions? Well, thank you.
It's really important to mount your plates correctly when you're going to press for a number of reasons. The main one is this. When you're mounting plates, you want them all to be the same and as close to square as possible, obviously. But when you go to press, and if they're not square, now you've got ink in the press, you've got to stop the press, take all the cylinders off and remount them. So instead of mounting those plates at your pre-press rate or your plate mounting rate, now you're mounting them at press time. Put it into dollars. If you have a press that's chargeable at $200 an hour and you have to remount the plates, you're now mounting your plates at $200 an hour. And when you're doing a set of like process plates, it could take an hour or so to mount them accurately. So it's important to get the plates mounted to the cylinders square and consistent from cylinder to cylinder. And there's a wide range of plate mounters. A couple of examples. This is about the most basic one you can get. It's a couple of blocks of wood and a rod going through it. you can get into a mounter that's a tabletop mechanical mounter. This is a quality mount mounter made by ConverSource in Chesterfield, Missouri. There are a couple of other options that you can get to also. There are video-based mounters. This is an AccuMount, and we're going to show you another one in a few moments, which will be a Mark Andy ConverSource PM video mount. The interesting thing about plate mounting is this. Any of these systems have the same capabilities. They can all mount a plate absolutely dead nuts accurate on. But you get into quite a difference in the required amount of skill. If you're going to mount a plate with a couple of blocks of wood and a steel rod through it, you better be one plate mounting rocket scientist. But as you spend more and get more sophistication in a plate mounter, you'll find that people with less experience can mount a more accurate plate in less time. This is a PM video mount plate mounter, and it's available from ConverSource and also from Mark Andy. To save a few minutes, I went ahead and I had mounting tape already applied to the printing cylinder. Putting it into the mounter is quite easy. You just press this foot pedal, those two centers separate, you place it in, release it. It's locked into place securely. Take the plate, you decide where it is going to be across the cylinder, insert it under the plate clamp. I drop this switch, which in turn clamp the printing plate into position. Now we take the two video cameras and we move them into position. What you're going to do is you're going to pick up the left edge of the left register mark and the right edge of the right register mark. Then we're going to take these knobs and we're going to dial them down in an adjustment. So that the left mark and the right mark line up perfectly and they look just like one mark. I'm referencing off of this mark, which is the same left and right. After it's in position, I'll take the printing cylinder, peel the liner off of it, move the cylinder up into position, lay the leading edge down, make sure that it's adhering to the cylinder, lifting the plate clamp, and while smoothing it, you smooth the plate down onto the exposed mounting tape. Resulting in a perfectly mounted straight plate. This is a ConverSource AccuMount video mount plate mounter, and it's quite similar to the PM video mount that we just looked at. It's using the same video technology, the same electronics, but in a tabletop version. What it's going to do is it's going to allow you to view the plate while you're mounting it, and it's not going to have the skewing table. Its advantage is that it's smaller and it's quite a bit less expensive than the PM video mount system.
Hello, my name is Dan Foy. I work for Harper Corporation of America. I work for a division called Harper Scientific. We sell parts and supplies to the printing industry that complement our main product line of the Analox rolls. I've been with Harper for about 8 years. Started off in mechanical engraving, moved into the tech service department, and spent the better part of the past 8 years in and out of press rooms, inspecting Analox rolls, doing banded roll designs, banded roll tests, banded roll sample evaluations, do a lot of seminars to press operators, floor level personnel, as well as management, executive level. Harper's approach to Flexo is to be as scientific as possible. Okay, we don't want guesswork. We've got a lot of experience we can draw from, but typically things you do, say at Raffletech, if you're trying to do the identical thing at Silex, probably not going to use the exact same Analox rolls as far as line screens and volumes. It may take different applications. The basic idea will be the same. So we've got a lot of experience we can draw from, but we want to be scientific. We want to remove any guesswork. We want to minimize the variables. We want it to be accurate, consistent, predictable. And that's what Flexo has not been up until probably the past 5 years. Okay, it's been relatively low quality process, but with improvements in Analox rolls, inks, plates, all the components make up the process, Flexo is getting better, and it's getting to the point where it's taken a lot of business away from the other printing processes, offset, litho, and gravure. Our approach is we start with quality engraving. Okay, we believe we make the best, and it makes sense. Okay, if you don't have good analox rolls, you're probably not going to be able to print as well as you'd like to. We want to select these rolls scientifically. We want to do some testing to determine what in fact is the volume, the line screen that's going to work for what you're trying to accomplish. In the process, we're all going to also think about putting down thinner ink films. One of the reasons Flexo has been a traditionally lower quality process than the others, offset, litho, and gravure, is that they put down thinner ink films. Thinner ink films are easier to control, less dot gain, better image contrast, just better overall print quality. So that's what we're trying to do. I'm going to start with a little bit of history. When I first started with Harper, that's exactly what I did, mechanical engraving. Simply take a hardened steel tool. It's got a pattern on it. This is a very coarse engraving. This is probably 16 cells per inch. You take that pattern off the hardened steel tool and press it into the softer material on the analox roll. You're simply going back and forth with that tool until that pattern is fully raised on the analox roll that's on the tool. Okay? This is what the engraving looks like when it's fully finished. Okay, you've got relatively thin cell walls. You see the tops of the cell walls here. This is what we call a post area. These are what we call quad-shaped cells, and they're engraved at a 45-degree angle. If you imagine the axis, the longitudinal axis, the analox roll going east to west here, that's 45 degrees in relation to that axis. That's where the orientation of all these cell angles comes from the longitudinal axis, the analox rolls. Chrome has its place. Okay, now Silex, what do you do with chrome rolls?
We've got a real old custom-made Mark Andrews press. We use solvent-based ink doing a continuous, mostly solid printing.
Okay. Okay.
200 count.
Okay. Chrome rolls are obviously still made today, and they're still employed. They have their place. Traditionally, or it's not for high-quality print. Okay. They do have some benefits. It looks real nice, doesn't it? Real crisp, real sharp engraving. Very, very slick, very smooth, relatively low surface energy compared to ceramic. Makes it very efficient. However, the chrome layer itself is very hard, but you saw from the previous slide, the material that we have to engrave into is relatively soft. So the chrome layer is hard, but it's very thin. Material underneath that's soft, that's very susceptible to damage. Okay? This is what a new chrome roll looks like. Okay? Again, relatively thin cell walls, well, at least when it's new, but they're tapered. You can see they're tapered. As they wear, they're going to get wider. The post area is relatively large. Okay? Keep this in mind, because when we go from a quad-shaped cell like this, when we're burning cells with a laser, to a hexagonal-shaped cell, we're basically doing the same thing. When we went from mechanical engravings to laser, the natural progression was to go from 45-degree quads mechanical. If it's not broke, don't fix it. 45-degree quad laser. We're working with a round laser beam. We end up with these wide walls and large post areas when we try to do 45 quads with a laser. Okay, so as it wears, walls get wider. Now the same is true of laser engraved 60-degree hex-shaped cells. Okay, the walls are tapered, so as they wear, they're naturally going to get wider. Walls get wider, lose depth, and our post areas increase in size too. And naturally, we're losing volume. You lose volume, you lose color. Okay. Chrome rolls, traditionally used with two-roll metering systems. You've got a rubber roll that rotates in the ink pan, rotates a slightly different speed than the analox roll, creates a wiping action. They're very speed sensitive. You imagine it's fixed at the ends, but it's not supported in the center. The faster the press goes, the more hydraulic action tends to develop between the rubber roll and the analox roll, and it's going to force them apart. So you'll end up with an inefficient metering of the ink in the center of the roll if you go too fast. So it's kind of a speed-sensitive process. It's also very subjective. Mark sets impression with a rubber roll and chrome roll, gets a certain amount of color. I come in and do it. Maybe I've got a little bit more experience. I set the proper impression. Maybe I get a little bit less color. So it's very subjective. You can't use a doctor blade with a chrome roll, at least practically. Maybe you can use a plastic blade, but again, you're not going to print any real high-quality work with a mechanically engraved chrome roll. Very versatile screen count. You can go from 11 cells per inch up to 500 cells per inch with chrome. Volume range, maybe down as low as 2 BCM to up over 100 BCM. Okay? Most of the chrome rolls I still see today are in coating applications, looking to put down very viscous, very sticky materials that are inefficient as far as using ceramic rolls. Difficult to clean, don't transfer as well. Okay? Chrome has its place. Okay, at some point in the development of analox rolls, they said, okay, chrome's good, we're getting pretty good metering, but these rolls don't last very long. They're damaged very easily, they wear out quickly. let's try the application of ceramic. That's exactly what we're looking at.